we already have seen in the last class, and I gave you the example of a train, a weak person catching train from Mumbai and wants to go to Delhi. So train carries the person from one terminal to the other terminal. Same way, same pattern is followed in the communication system as well. So what actually the modulation is? So modulation is the process. Modulation is the process of changing some characteristic, okay, either amplitude, frequency, or phase of a carrier signal in accordance with the intensity of the your data signal. So that process is called as modulation. You cannot alter the data. Data is very important. You should not disturb the data. But as per the convenience of the data, the carrier should be modified. Okay, carrier is empty signal. You can change its properties. Data should not be changed. So carrier properties should be changed in accordance with the change in the data. Data can be of different form. If you right now I'm talking to you, so this is voice is going from my end to your end. If I start typing something on the chat box, so SMS message will go. Okay, message will have different properties. Voice will have different voice. There's a pressure variation at my end, then your end also. So properties are different, slightly disturbed. So when we speak, and if you see the signal what I speak onto the CRO, it will be a variation of the amplitude in my voice. Okay, frequency can be different, frequency will be different. So properties are different. If you start typing something, so maybe the voltage will be same, but uh, other parameter, instantaneous voltage will be different. Okay, so different properties. So you should not disturb the data, but carrier can be changed. So this process where carrier property change as per the change in the data signal is called as the modulation, and this is what is used in the communication system. So modulation exactly means to change. Okay, modulation exactly means to change. So in modulation, what is done? Some characteristics, some properties of the carrier signal is changed in accordance with the uh, uh, change in the data signal. So if data signal amplitude is changing, then carrier amplitude should change. If data signal frequency is changing, then carrier signal frequency should change. So depending on what property of the carrier you are changing, modulation type will be different. Clear? Yes.
Yes, sir.
Okay. Why at all you would need modulation? Last lecture I gave you all the example. If I start speaking to you, you are just in front of me, maybe at a distance of 5 feet or 10 feet. I'm not using any device. You are not using any device. You are able to hear me. But if the distance between the two person increases, say it becomes 1 kilometer or 2 kilometer, then if I start sending my voice through air, then you will not be able to hear that sound. It is because the sound goes in spherical wavefront. P upon 4 pi r square is the intensity of the sound. Okay, so with respect to the distance, the intensity goes on decreasing. The sound energy has to fight with so many obstacles, so many resistances present in the air, and towards the end, the intensity will become so small, it will simply not audible only at the receiver end. So, so there is a need of some technology to be incorporated into it, and the technology is called as the modulation. So modulation is extremely necessary in communication system, especially for long range communication system, because of the following reasons. Number one, practical antenna length. Nowadays, since like technology is slightly different, uh, uh, if you remember and if you go to the archive, you will see that the earlier phones, your mobile devices, they were having antenna incorporated into them. Archive will also show you. Earlier, we used to have the antenna placed onto our terrace. When we used to switch on the TV, we used to adjust the position, the phase of the antenna, so that signal should come properly at our places. Have you seen those archive about antennas incorporated onto the terrace of our houses? Are you aware of those things? Yes or not?
Yes, sir.
Okay, so nowadays technology is different. Now the nearby operator or this thing takes care of that. If you are using some local cable operator, then they will have the receiving this antenna placed there, and from there now it is a series of digital to digital communication system is happening. Analog to digital at their end, and then digital to digital is what is received at your home. So technology has changed drastically. So if you see the 50-year back, what was the technology, and now what is the technology? There is a complete transformation. Earlier, for single second information, people used to say that telegram. Okay, not this WhatsApp telegram, but earlier the telegram was used to convey fast message from one terminal to the other terminal, and the telegram used to be a single line. Okay, people used to communicate. If fast communication should happen, then people used to use this telegram, and the cost was for one line. I'm talking about 30-year back. So for one line, that time the cost was around 30 rupees, 35 rupees. Now you see the technology has changed in 35 years. Now you can talk multiple hours without paying any single paise. See the transformation of technology from just in 30 years, how much the technology has transformed. Okay, so why the modulation is required? Because of the length of the antenna requirement. So uh, uh, derivation shows we will not derive the formula. Uh, this derivation is available in any electrical engineering book. The length of antenna required for transmitting a signal having wavelength lambda. So the formula comes out to be the length of the antenna equals to lambda by 4. So for efficient transmission. So if you want to transmit a signal having wavelength lambda through an antenna, then the length of the antenna should be equal to lambda by 4. For example, if the frequency of the signal is suppose 30 hertz, if the frequency of the signal is 30 hertz, velocity of sound, so now, if you want to communicate via air, so radio communication will happen. So C you can take as 3 into 10 to 8 meter per second, okay, because it will travel through air. Frequency of the signal is suppose 30 hertz. Then the length of antenna required is 2500 kilometer. Now, how this is come? Uh, the detailed calculation I am showing here. So Uh, now, I ask you to find out what will be the length of antenna if the frequency of the signal is 30 hertz. Now, you know that lambda equal to C by n, or C equal to n lambda, C equal to n lambda, so lambda will be C by n. See, if the communication is happening through air, so C will be 3 into 10 to 8. Frequency of the signal, I told you to take 30 hertz. So the wavelength comes out to be 1 into 10 to 7 meter. 1 into 10 to 7 meter, I can rewrite as 100 into 10 to 5 meter. Okay, 100 into 10 to 5. So lambda is 100 into 10 to 5. Now length of the antenna required is lambda by 4. So 100 into 10 to 5 divided by 4. So it comes out to be 25 into 10 to 5, or 2500 into 10 to 3. 10 to 3 means kilo. So 2500 kilometer. So this is how I have calculated the length of the antenna. See if you have understood this small calculation.
Yes, sir.
Okay. So with this example, if you see, if the frequency with which you are sending the signal, if it is 30 hertz, then the length of the antenna required is 2500 kilometer. Can you imagine 2500 kilometer will be how long? What is the length of antenna from east to west? Length of India from east to west, somewhere around 2000 2800 kilometer. Okay, so If you want to communicate to some person with the frequency of 30 hertz, then the length of antenna required will be 2500 kilometer. 2500 kilometers. Imagine, this is highly impracticable. Don't you see? Don't you think so?
Yes, sir.
So therefore, it is highly impracticable to design an antenna with such a large length. It is very difficult. So when the frequency is 30 hertz, length of the antenna is 2500 kilometer. If by some mean, if you can increase the frequency to 3 kilohertz, then the length of the antenna required will be 25 kilometer. And if the frequency becomes 3 megahertz, the length of the antenna becomes 25 meter. Same calculation. So I'm just changing the frequency of the signal, and the calculation will show you the height of the antenna goes on decreasing as you increase the frequency of the signal. So for 3 megahertz, the signal, the antenna length becomes 25 meter. So which means that as the frequency of the signal increases, the length of the antenna or the height of the antenna required will be less. Okay, so lesser and lesser will be the height of the antenna required if you want to communicate at higher frequency. Is that clear?
Yes, sir.
uh, but usually we will not be able to speak with the frequency of 3 megahertz. So in the last class, I told you maximum you can speak is around 9.4 kilohertz. Okay, and telephone devices, they don't allow more than 3.328 kilohertz. Okay, so how it is then possible? Because the even if you talk at say 3 kilohertz, the length of antenna is 25 kilometer, which is from CST to somewhere around Ghatkopar. CST to Ghatkopar. Okay, those who are staying in Mumbai, they will know CST to Ghatkopar distance is around 25 kilometers. That is also impracticable to design an antenna of such a larger height, such a greater height. So by some technique, you have to design some technique where even if the frequency of the signal is less, but you enhance the overall frequency so that frequency should become very high, and the length of antenna required will become very small. So that was the first reason why you need modulation. So by modulation, there is a possibility of enhancing the signal frequency by some technique, so that the length of antenna required will be very small. Okay, if you don't use the technology, length of antenna required will be very large. If by some technique, if you can just enhance the frequency of the signal, then length of antenna required will be very small. The second reason is that don't look at this what I'm displaying here. Just listen to me what I'm saying. So we all know that energy of signal depends on the frequency of the signal. Do you all agree with me? E equal to h into nu. Yes.
Yes, sir.
So nu is the frequency of the signal. So as nu increases, h is a constant. So energy of the signal will increase. Okay. So more is the frequency of the signal, more is the energy of the signal, and you know that energetic signal will be able to travel a larger distance because it can fight with the obstacle. Okay, without losing much amount of energy because already energy is very high. Okay. So the energy of a signal. Now you can look at this PPT. So the energy of a signal depends upon its frequency. Greater the frequency of the signal, greater will be the energy contained by the signal, energy contained into the signal, energy possessed by the signal. More is the frequency, more is the energy. So as audio signal frequencies are very small, usually I told you the range. Therefore, audio signals cannot be transmitted over large distance if they are directly released into the space, into the air. They will not be able to travel large distance. Okay, audio signal, your sound signal will not be able to travel larger distance. And so if by some technique, so by some technique, if you can enhance, by some technique, if you can enhance the frequency of the signal, then energy of the signal by default will increase, and therefore long distance communication, you can think of, you can just think of long distance communication to be possible. Clear? Understood the two reasons. The length of the antenna required will become small. You can have larger operating range for the signal if you can enhance the frequency of the signal, overall frequency of the signal. So this I in both the example, in the first case, the length of antenna required will be minimum if we can design, if we can devise a system where you can enhance the overall frequency of the signal, original signal. Okay. In the second case, operating range, and I told you here also, if you can enhance the overall frequency of the signal, you can increase the operating range. So in both the cases, I have toys this sentence that if by some technique if you enhance the frequency of the signal, so that technique is the modulation. Okay, that technique where you are enhancing the frequency of the signal, that technique is the modulation. That technique is the modulation. Okay, so modulation is the technique where you will actually try to enhance the overall frequency of the signal. So modulation is a very broad classification. It has multiple classification under its umbrella. So modulation is just to change. Nowadays in electronic communication, at every step, whether you type some message on the WhatsApp or on Telegram, whether you speak something, whether you hear FM, whether you hear AM into your mobile phone, whether you receive signal at your television set, all these are using some kind of modulation. Maybe the types will be different. Okay. So before going to the further part, let me just give you a broad classification of what kind of communication systems you have, and then I will come to this what I'm displaying here. Now, uh, you have the television receiver set at your home. Am I right? All of you must be having. Am I right?
Yes, sir.
Okay. Now, in your television receiver set, you can receive the signal at your home. Okay, but the other way around is not possible. You will be able to receive Star Plus. You will be able to receive Star One, NDTV India, so many other channels, Sony channels, so many channels. So, is it possible for you to send information to them via your television set, via your TV set? Is it possible that you do the other way around? You send some message to them via your telephone, via your television set, normal television. I'm saying, not possible, no. This kind of communication system where you can only receive, where you can only receive the information, you can't send the information, you can only receive. It's called as a simple type of electronic communication system. So simplex mode of electronic communication system. So your television receiver set is that example. You can receive signal from different broadcasting stations, but you cannot send them back. So this is simplex type of communication system. There is another example available, walkie-talkie. So in walkie-talkie, there are two devices. So when person A is speaking, person B has to receive. When person B is speaking, person A has to receive. Usually, the police people, if you walk through some traffic signal, you must have seen they are having walkie-talkie. So when I'm speaking, unless I tell over, the other person will not be able to send the information. When I'm speaking, suppose I'm person A, you are person B, I'm speaking, I'm continuously speaking. So unless till I say over, then the other person's information I will not be able to hear. So both can transmit and both can receive, but both can transmit and both can receive, but not simultaneously. Not simultaneously. So this is one way. So in one way only the information can go, and when I'm saying over, now information from my side will not go to that line. Now the other person has to speak, and when other person will send the information towards you, and the other person will say over, then only I can start speaking. So both channel exists, both can communicate, both can speak, both can hear, but not simultaneously. So this is called as half duplex type of electronic communication system. Simplex type, you can only receive. Half duplex, you can receive, you can transmit, but not simultaneously. So this is the half duplex. Now there is another category which nowadays we all which nowadays we all are using your mobile phone system. Here you can send information, you can receive information simultaneously. So this is called as full duplex type of communication system, like two-way road. On one side vehicle can go from in one direction, on other side vehicle can go in the opposite direction. So both way the transmission and receiving thing is possible. So that type is called as the full duplex type. So there are basically three broad categories in the electronic communication system. Simplex type, where information can only be received. Half duplex, both transmission and receiving thing is possible but not simultaneously. Third one is the full duplex, where you can transmit, you can receive simultaneously. Is that clear to everyone?
Yes, sir.
Okay. Now coming to this point, modulation. So basically, modulation. There are two broad categories in the modulation. So one on the left side, if you see, is the analog modulation, continuous wave modulation. So this is a kind of analog modulation. On the right side, whatever you are able to see, these are all digital modulation. Analog modulation is very simple. You have amplitude modulation, you have frequency modulation, you have phase modulation. So these are all analog modulation. And on the right side, you have digital modulation, pulse code modulation, PWM, PPM. These are all the phases. These are all the phases of a digital modulation. So in analog modulation, usually uh, when we speak right now, I'm speaking. So all your devices and device at my end, it is using a kind of FM, frequency modulation. Okay, the picture signal what you are able to right now see on your device. Okay, the picture what you are able to see on your device, it is actually AM, it is amplitude modulation. Picture is AM, voice is FM. The information which you receive at your home via your television set. So in your television set you receive two information simultaneously. Can anyone tell me what are those two information which you receive simultaneously? uh, am I there in the Google Meet?
Yes, sir. Yes, sir.
Okay. So at your home, in your television set, you receive two signal simultaneously. So those two are, one is the voice signal and another one is the picture signal. Signal, and you see the picture signal, and both are synchronized. Although both are transmitted separately via technique which is called as the independent sideband, that I will cover when I will be discussing the single sideband technology, why that technology is so much effective and why it is very essential in the electronic communication system, single sideband. So that is a kind of independent sideband. Voice is also coming at your home. Picture signal is also coming, but both of them are slightly associated with different kind of modulation. Voice signal, what you hear at your home right now, what you are hearing me, is the frequency modulation. So when I'm sending the signal, voice signal through the microphone, through my device, something is happening. The frequency is enhancement is happening. Okay, the frequency of the carrier is changing in a fraction of second, and whole communication is going at your end. So voice is going through FM. At the same time, what PPT you are able to see, the whole information is going from my end to your end via AM. So see, the combination of the two, AM and FM, both are incorporated. So one of the sideband is the AM, one of the sideband is the FM. Both are incorporated together. They are going at your place together. Is that clear?
Yes, sir.
Okay, so this is how the technology is involved. So at your home, AM and FM both are being received when you see the television. When you type something on the mobile phone, when you type something on the laptop, so it is a series of the digital thing. So when I write something, have you heard the ASCII code name? ASCII, American Standard Code for Information Interchange. Okay, so that is the universally accepted code. So if I write a small a means decimal number 97, and that 97. So if I write Ajay, AJAY, so small a, as soon as I write a small a, there will be the decoding. Small a will be number 97. 97 will be converted into its binary number. Binary number will be then converted into its high and low waveform, and that waveform will be modulated, and that waveform will travel through the air to the nearby uh, uh, tower, and from there the information will go through the fiber optic cable at your nearby tower, and this way the communication will happen. So when you start typing something, the whole process comes under the digital modulation. When you speak, when you send the picture signal, they are AM signal. So what is amplitude modulation? So you have a signal. This is the information. Uh, y-axis is the amplitude, x-axis is the time. So with respect to time, there is a variation in the amplitude. Now, diagram on the lower side, where I'm moving the cursor, is the carrier signal. Can anyone tell me what is the difference between this carrier signal and the data signal?
The frequency of the carrier signal is higher, much higher than the information signal.
Correct. So if you see the signal which is on the lower side, it is compressed. So you have so many waves compared to this diagram number one here. Okay, so this is well spread, and this is very compact, very compressed. Compressed means the time period between this start point to this end point is very small. So time period is very small means frequency is very high. F equal to 1 upon t. Okay, t is the time period. Now here if you see, it is widely spaced. T is large, so frequency is small. Okay, now what amplitude modulation is? So here if you see, this is the data signal. I told you data signal is very important. Data is very important person. You should not disturb the data, but carrier can be changed. Carrier can be changed. Now here if you see, the amplitude of carrier is constant throughout. The frequency is also constant. Now, what is amplitude modulation? So, in amplitude modulation, what is done? The amplitude of the carrier will change. The amplitude of carrier will change as per the variation in the data signal. Now, here if you see, can you see the mouse pointer which I am moving around here? The data signal. Yes. Can you see the mouse pointer or not?
Yes, sir.
Okay. Now here the data signal amplitude is high. So the in the resultant signal, the carrier wave amplitude should become high here. Now your data signal amplitude is minimum. It goes on the negative cycle, negative maximum. So here your resultant signal amplitude should become minimum. Here again maximum, minimum. So resultant wave will look like this. So here if you see the envelope, so here the amplitude of the resultant signal is maximum, where the data signal amplitude was maximum. The resultant signal amplitude becomes minimum, where the data signal amplitude was minimum, and the cycle is repeated. Is that clear to everyone?
Yes, sir.
Okay, so same thing I'm writing here. So in amplitude modulation, only the amplitude of the carrier signal is changed in accordance with the change in the data signal. However, the frequency of the resultant signal remains same as that of the carrier signal. So the frequency, if you see, there are two things. So can you see the envelope which is here on lower side and upper side, and inside the envelope there is a carrier signal. So although the amplitude of carrier has changed, okay, but the frequency of carrier will remain same as the carrier frequency. But but if you see the maximum of this envelope, it coincides with the maximum amplitude of the data signal. The minimum of this envelope coincides with the minimum of this data signal. So the envelope frequency is same as the data signal frequency. Envelope frequency is same as the data signal frequency, but the carrier inside the signal which is there inside this uh, resultant signal, it is its frequency is same as the carrier signal. What I'm saying, if you see the envelope, the maxima of envelope coincides with the maxima of the data signal. The minima of the envelope coincides with the minima of the data signal. Again, maxima of this envelope coincides with the maxima of this data signal. So the frequency of this envelope, which is covering the information inside it, the frequency of this envelope is same as the frequency of the data signal. The frequency of the envelope is same as the frequency of the data signal, but the signal which is there inside this envelope, its frequency is same as the carrier signal frequency. Is the point clear to everyone? These 2 points.
Yes, sir. Yes, sir.
Okay. One more thing. One more thing. The whole information, because the why we are doing all this thing is just to convey information from one terminal to the other terminal. So in case of AM, the amplitude modulation, the information is contained in the amplitude variation of the resultant signal. So there is a variation in the amplitude which carries the information. So amplitude variation contains the information. It conveys the information in its amplitude variation. So, following points should be noted down. The amplitude of the carrier signal changes. Amplitude of the carrier wave change according to the intensity. So, this envelope amplitude I am talking about. Okay. So, the amplitude of the carrier signal changes as per the change in the data signal. This is point number one. Because you see, the carrier signal frequency remains the same, but the amplitude it is different. Am I right? Amplitude is maximum where the data signal was maximum. Clear to everyone?
Yes, sir.
Now, the amplitude variation of the carrier signal is at the signal frequency. I told you the envelope, no? The frequency of the envelope is same as the data signal frequency. So, same thing I'm writing here. Third point, the frequency of the signal which is there inside this envelope, it remains the same as that of the carrier signal. See if you have understood these 3 points. Yes?
Yes, sir.
Okay. So, an important consideration in amplitude modulation is to describe the depth of modulation. That is the extent to which the amplitude of carrier signal is changed as per the data signal. So, this is described by a factor called as modulation index. So, what is this modulation index? Okay. Uh, if you can see here, I have the carrier signal, I have the data signal, and I have the AM signal. Here if you see the minima of both the sides on the with respect to the equilibrium position, the minima on the upper side and minima on the lower side, they are touching each other. Am I right? Here the minima, they are not touching each other. Am I right? The minima
Yes, sir.
with respect to the equilibrium position, the positive minima and the negative minima, they are not touching each other. Here they are touching each other. So here in this case, this is a kind of 100% amplitude modulation. Now, how I have calculated, I have arrived at this conclusion that here in this case the modulation is 100%. So we have to calculate the modulation index. So modulation index is a parameter. Maybe you can note down in your notebook. So modulation index is a parameter which gives you the information, the strength of the modulation. Modulation index is a parameter which gives you the information about the strength of the modulation. It describes how strong your modulation is. Okay. So how it is calculated? So modulation factor or modulation index is equals to the amplitude change of the carrier signal divided by the unmodulated carrier signal amplitude. So maybe you can write down this amplitude change of the carrier signal divided by unmodulated carrier wave signal amplitude. Now, how to calculate here? Now, here if you see, let me take a simple example. So, with respect to the equilibrium position, the first diagram is the carrier signal. With respect to the equilibrium position, the maximum height is suppose 1 centimeter. This is the carrier signal. Data signal with respect to equilibrium position, the maximum height again I am taking as 1 centimeter. Now, here if you see, the maximum height is 2 centimeter. Okay, with respect to the equilibrium, the maximum height is 2a. Now here, if you see inside the envelope, there is a carrier signal. So the amplitude of carrier has changed. So what is the change? What is the maximum change? Don't you think the 2 centimeter minus 1 centimeter? So 1 centimeter is the change, the effective change, the effective change, the maximum change. I'm asking. So here maximum height is 2 centimeter. And what was the original height? Unmodulated carrier wave signal height. It was 1 centimeter. Am I right? With respect to the
Yes,
equilibrium
sir.
position. So 2 centimeter minus 1 centimeter. So 1 centimeter is the maximum height divided by. So how you calculate? So when signal amplitude is equal to the carrier wave amplitude, here the amplitude of carrier signal varies between 2 centimeter to 1 centimeter. So therefore the maximum amplitude change is what? 2a minus a equal to a. Am I right?
Yes, sir. Yes, sir.
So, and what is the unmodulated carrier wave signal amplitude? Here in this example, unmodulated means before modulation. What was the carrier signal amplitude? A only. After okay, so let me calculate. So modulation factor will be change in the amplitude of the carrier signal, which is 2a minus a, so capital A, divided by unmodulated carrier wave amplitude. So a upon a equal to 1, so 100%. uh, have you all understood this? Okay, so next example, you should give me the answer. What will be the modulation index? Okay, tell me what is the modulation index in this case. So here 50% is the right answer. Here you have carrier signal equilibrium position. With respect to equilibrium position, the maximum height is suppose 1 centimeter. Data signal amplitude is only 0.5 centimeter. Maximum here goes, see, 1 centimeter plus zero point 0.5. So 1.5 will be maximum, and 1 minus zero point 0.5 is zero point 0.5. Zero point 0.5 will be minimum. So maximum will be 1.5, minimum will be zero point 0.5. Now here if you see the maximum is 1.5 centimeter, and what was the original? 1 centimeter. So what is the change? 0.5 centimeter. Am I right? So let me write here. So here the amplitude of carrier signal varies between 1.5 centimeter to zero point 0.5 centimeter. So the maximum change is what? 1.5 minus 1. So zero point 0.5 uh, A, and what was the original? Original was capital A. So modulation index in this case will be zero point 0.5 divided by zero point 0.5 A divided by capital A, so 50%. So here in this case, the signal is 50% modulated. Example, with this example, if you see, we have seen the two examples. In previous case, it was 100% amplitude modulation. In this example, it is 50% amplitude modulation. So your modulation factor, we will solve a few problems and we will try to understand in depth how the modulation index is very important in avoiding the or in overcoming the interruption, noise interference with the AM. I don't know if you heard about the AM. Have you all uh, listened to AM at any point of time at your home? AM at your home? Have you heard AM?
No, sir.
Or you have not heard? Okay. Are you aware of AM frequency bandwidth from which point to which point? Okay, at least FM you must have heard. Am I right?
Yes, sir.
FM is from 88 megahertz up to 108 megahertz. 88, okay, 91.1. You must have heard, no? 91.1. FM is 88 megahertz to 108 megahertz. Usually we don't say mega, we just say 91.1. Okay, you tune to
Yes, sir.
91.1, you tune to 93.5. But usually FM is in megahertz, AM is in kilohertz. AM is from Vivid Bharati 535 kilohertz up to 1600 kilohertz. AM is 535 kilohertz to 1600 kilohertz. Usually, AM has been given a lower spectrum in the bandwidth. FM has been given the higher spectrum in the bandwidth. So if you see in both the example, this 50% modulation and the 100% modulation, here there is a variation of the envelope. The amplitude of this envelope changes if you see. And if you see the all interference in the air, try to touch the CRO probes, you will find a signal which will detect a kind of not a very strong signal from your heartbeat or from your body, but if you touch the CRO red terminal, okay, so you will see there is a continuous variation of the amplitude or the kind of noise signal which you can see. So all noise signal whatever are present in the air, they are always in the form of the amplitude variation. So if by some means, since all this AM is happening through air from the broadcasting station to the nearby tower, so all man-made noises, all natural noises, they are in the form of amplitude variation. So if if they get stuck or they get interfered, they get absorbed here by some means, so those amplitude variation and this data amplitude variation, they will get mixed up, and for the receiver it will be very difficult to actually distinguish what was the original information amplitude variation, what is the noise amplitude variation. So it will be very difficult for the receiver to actually distinguish between the actual data signal which is there in the amplitude variation of the your resultant AM signal and the noise signal. So therefore you see most of the time, and if you're not experienced, please try today itself, try to listen to AM, tune to any frequency from 535 to 1600 kilohertz, and tune to any given frequency and see the how good the quality of the signal in AM compared to FM. Which one is good? AM is good or FM is good as far as the quality of the signal what you receive at your home is concerned. So this is a small homework for you.